implementation. Third one, more utility collections. Okay. Core collection interfaces, how many are there? 10. The 10 completed. General purpose implementation, how many are there? 10. Just 2 completed. What are completed? RLS, linked list. Next one, has set. This has set definition also I given. What is has set? It is an implementation of hashing technique with array representation. It is an implementation of hashing technique with array representation. Here, what is hashing? Hashing is a technique in which insertion, deletion, and find operations done in a constant average time. Hashing is if the element is at the end also, element can be anywhere in the list or set, anywhere in a set, anywhere. It will find very quickly as compared to sorting, sequential sorting, binary search, sequential search, binary search. Okay. Now, hashing, based on hashing, it is implemented. Next node. This is written up to here. Next. It does not allow duplicate elements. It does not allow duplicate elements because it does not allow duplicate elements because it implements set interface. It does not allow duplicate elements because it implements set interface. It allows null values. It allows null values. It allows null value, one value, because duplicate not allowed, no, one value. It allows null value. It supports both homogeneous elements and heterogeneous elements. It supports both homogeneous elements and heterogeneous elements. It supports both homogeneous elements and heterogeneous elements. Homogeneous means same type. Heterogeneous means different types. Okay. Has said default initial capacity is 16. Has said default initial capacity is 16. As said, default load factor is 75%. As said, default load factor is 75%. As said, default initial capacity is 16. As said, default load factor is 75%. Just close the door. See, 16 elements initial capacity, default initial capacity 16. Okay. Load factor 75%. That means out of 16, 75%, 12. Once if the 12 elements are filled, next 16 allocated. But your doubt is 4 elements memory wasted. But very quickly searching means possible, but sometimes memory wasted. This will be happen. I'll explain why like that. I'll explain. As said, default initial capacity 16, but as said, default load factor is 75%. 75% elements are filled. Then what will be happen is next is after filling 12 elements, next 16 elements memory allocated. That type written. But here 4 elements memory wasted. 4 elements memory wasted. But very quickly it is searching possible. That is the reason it will be done like this. I'll explain. I'll show you with example program. Next. See, these all remember, don't forget. It is an implementation of hashing technique with array representation. Here, this is hashing definition already given. Here, it does not allow duplicate elements because it implements set interface. It does not allow duplicate elements because it implements set interface. It allows null value. It allows null value. Okay. It supports both homogeneous elements and heterogeneous elements. Homogeneous, heterogeneous. Different type elements possible. Same type of elements also possible. And capacity 16. Load factor 75%. Okay. Next, here insertion order is not preserved. 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 Your order is not maintained. Array list, linked list, whatever we given order, that order only output comes. But here order not maintained. Order not maintained means it will maintain hashing order, but you cannot predict. That is the reason not hash set is an unordered set. 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 Order is, that's what you're calling, not meant insertion order, not preserved. That's what unordered set will call. These all about hashing. These all about hashing. Okay. Now I'll explain. Here has set HS equal to new has set. If I write, is it type safe or type unsafe? Unsafe. Okay, it is unsafe. Now, if I write like this, is it safe or unsafe? Is it homogeneous or heterogeneous? Homogeneous. If I write like this, if I write like this, heterogeneous. Okay. Now I want to maintain integers. But if you want to maintain primitive type integers also, you must write integer only. It supports only reference data type. But you should not write like this. It's an error. It is syntactical error. Okay. Program will not compile. Why the given reference type is, if it is primitive type, only 8 data types. Reference type, n number of data types you can write. Employee also one class, that is also one data type. Student also one class, that is also one data type. And even primitive also possible with auto boxing feature. That is the reason they given reference type. Okay. Has set in which package? Util package. What we have tried? Import java.util.star. Now, here also add methods insert. Here collections, what will be there? Adding element, inserting element, removing element based on index, based on element, modifying element, updating element, deleting element, and displaying number of elements, converting into array. Like this, methods are there. What you do is one class, example, array list. Just you open like this, CMD run as administrator. What you do is here java p java.util.array list. Here, these all array list methods. These all array list methods. These all methods except from here onwards. These from no, from here onwards, not possible. That is again lambda expressions have to teach. Iterators lambda expression. But these all few methods you can understand, you can call, you can see the output. Just what you do is call this method, see the output. Call this method, see the output. Call this method, see the output. These all methods you try to do it. Converting into array, cloning, converting into object array, converting into type safe array. These all you can do it yourself. Call the method, see the output. Just practice like that. Okay. One collection, if you practice, remaining all collections, same type will be there. In all, here what will be there? Adding, inserting, deleting, updating, modifying, these only will be there. But different types output. See. HS dot add one number. HS dot add one more number. HS dot add one more number. HS dot add one more number. HS dot add. Like this are written. System dot out dot println HS. Okay. Now, if it is array list, what is output? 83, 45, 32, 17, 68. If it is linked list, what is output? Same. Array list, linked list, same output comes, but internally different. You studied. Now, this program, if I compile and execute, what is output coming? You observe. Java C demo.java. Java demo. Now, you observe 32, 17, 83, 68, 45. Is it my order? My order means first one, 83. So, it is not my order. Is it ascending order? No. Is it descending order? No. It is not my order. It is not ascending order. It is not descending order. That's what this point I given here. Here, insertion order is not preserved. As said is an unordered set. But here also one order is there. That is hashing algorithm order. Hashing algorithm, if you know, this is, you can give answer. I'll explain. Hashing algorithm, I'll explain. First write this program. Now, hashing algorithm order, I'll give. I've written. If it is array list 83, 45, 32, 17, 68. If it is linked list, again 83, 45, 32, 17, 68. But it is has set. It is not array list, it is not linked list, has set. First you write this output also. Why we are getting like this, I'll explain. So collections framework, it is a most important topic. Okay. Most important topic. And even new features also most important topic. Now further up to last class important only. Whatever you studied previous programs, Java streams, serialization, network programming, not much important, but these all important, compulsory. Okay. Now you observe 32, 7. Now this order, why, how you are getting, why we are getting like that, I'll explain. Suppose you assume like this as it is stored, assume. Like this, assume, just don't write, assume. 83, 45, 32, 17, 68. Assume. Now, there are, one is sequential search. Next, binary search or hashing. Three concepts, searching purpose. Sequential search, it is search. First, it is sequential search. You are searching for 83. How many iterations? 1. You are searching for 45. 2 iteration. You are searching for 32. 3. You are searching for 17. 4. You are searching for 68. 5 iteration. If the element is left side, 1 iteration only. If the element is last one, right side, 5 iteration. There is a gap. Sometimes very quickly, sometimes it takes time. Suppose if it is binary search, first elements are sorted. 17, 32, 45, 68, 83. Suppose you are searching for 17. But first it is search. How many elements are there? 5. 5 by 2. 5 by 2? 2. Then 2 place it is search. 0, 1, 2, 3, 4. 5 by 2. It is search in 2 place. If you are searching for 45, 1 iteration. Suppose you are searching for 32. Then you will get it 2, not there. Then left side, 2 by 1. 2 by, like 5 by 2, 2. 2 will get it. 2 by 2, 1. 1 it will search. This is 1 iteration. 2 iteration. This is 1 iteration. This is 2 iteration. This is 3 iteration. If it is right side, what will happen? 2 plus 4, 6. 6 by 3, 2, 3. Here it will search. Here it will search. But if the element is exact middle, 1 iteration. If the element is this corner or this corner, 3 iteration. If the element is here middle, 2 iteration. But here also gap is there. Now 5 elements on, suppose 1000 elements. Still gap is there, no? But you observe here. First, here 16 elements memory allocated. 16 elements memory allocated. Now, this index is 0. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Now, like this, 0 to 15. Now, first, while inserting only hashing algorithm applied, what will happen is 83 modulo division 16. What will get it? 16 5 ja 8. 3 place 83 stored. 3 place 83 stored. Next, 45 modulo division 16. 16 3 ja 48. 16 2 ja 32. Reminder 13. 13 place 45 stored. Okay. Next, 32 modulo division 16. 0. 0 place 32 stored. 17 modulo division 16. 1. 17 stored. 1 place. 68 modulo division 16. 16 4 is 64. Reminder 4. 4 place 68 stored. You see your output already output written. No? What is the first element? Next, 68. That is output got it, no? Now you observe. Suppose you are searching for 32. 32 modulo division 16, 0. It goes to 0. One iteration. You are searching for 45. 45 modulo division 16, 13. Directly it goes to 13. One iteration. You take any element, one iteration. Okay. Sometimes what will happen? Reminder same comes. Okay. At the time, 3 place already is there. 4. 4 already is there. 5. Then what will happen? It will not search sequential. It will not search binary by 2 by 2. It is the reminder, based on reminder, it will search no. Dictionary, how will search? Like this only. This dictionary technique. In dictionary, what will do? You are searching for hashing meaning. Will you search first page, second page, third page like that? No. Dictionary by 2 by 2? No. You will go to H. Now here reminder is that reminder. There, not there. Next. H also, again many will be there. Later HEA. Later HAS. Later HASH. Like that will search no. Here also, maybe many elements are there. Same location. Next element. Next element. Sometimes what will happen? Many elements same comes. Next. That's what 4 elements wasted memory. That's what next 16 allocated. If 12 elements are full, it will not wait for until remaining 4 elements. Next 16 allocated. Memory wasted, performance increased. That is the reason it will maintain. Nowadays, many places hashing they are using because very quickly response. Okay, your hard drive, hard disk, how they're managing with hashing only. Your file handling, your file system, folder system, even your mobile data, whatever you stored in your mobile while retrieving, hashing only. Through hashing very quickly comes. See, you observe, suppose this example only. You are searching for 32. How many iterations? 17, 83. All one only, no? Element may be 0 place, element may be 13 place. But you are getting one iteration only. Sequential search, 1 also, 5 also comes. Binary search, 1 also, 3 also comes. But here, all one only maximum. In this example. Okay. So, as compared to sequential search, as compared to binary search, hashing is very quickly. This is hashing algorithm. Okay. Write this one. Like every day we are calling hash code. It is only. In a RAM, it is stored with a hashing technique. Address. Over. So while storing also, while inserting, because already given hashing definition, you read what I given. Hashing is a technique in which insertion, deletion, and find, three operations done in a constant average time. Sequential search, that is only searching technique. Binary search, that is only searching technique. But hashing, insert, delete, search, three operations in hashing. While inserting element also hashing technique. While deleting element also hashing technique. While searching also hashing. Three places. Say, best example, dictionary. Best example, dictionary. You're not searching like a sequential search. You're not searching like a binary search. You are using some technique. That is only hashing. Best example. Okay. Now, directly hashing meaning only if you want to search in a dictionary. Directly you'll go to H place. Okay. Here you are searching for 45. Directly it goes to 13 place. Directly 13 place it goes. Like that. Directly you'll go to H place. Okay. H, maybe next element will be HA. Let's HAS. Here also. Here not there. Next. Not there. Next. Like that, thousands of elements will be there very quickly possible. Like that. Like that, they written. Okay. That is initial capacity 16. 16 elements. It will not wait until completion of 16. It will wait until completion of 12 only. 4 elements memory wasted, but performance increased. Definitely there is an advantage, there is a disadvantage. Okay. We have to think about advantages, we have to continue. That's it. Anything in the world. Okay. Anything in the world, there is an advantage, there is a disadvantage. Suppose example, internet. Internet, how many advantages? So many advantages. Disadvantages also are there. Mobile, how many advantages? So many. With mobile, many disadvantages also are there. So advantage will be there, disadvantage will be there. Here also, memory point of view, memory wasted, but performance increased. Okay. Now, this is about hashing. Default 16 and 75% if it is filled, next 16. Null value allowed, duplicate not allowed. Now, here, one example you observe. After printing elements, system.out.println hs.size. Size means number of elements. Last class array list I given. Now, how many elements are there? Output is 5. Compilation, execution, 5. You observe here. hs.add 45. Okay. Now, here already 45 is there. Error will not come. Automatically rejected. So, this 45, it will not take. You return. First, it will check in the list. Logic already written like that. We are not checking. Already logic written. In the add method body only they written. Whenever you enter, it is there or not, it will check. If it is there, rejected. Error also will not come. Now, output, same output comes previous output only, you observe. File, save, I'll run. See, compilation, execution. See, are you getting any difference? 45 rejected. But how many elements are there? 5 only. That is not taken. So, sometimes in interview, this question they'll ask. Size. Seeing this many people will say 6. But they won't have this output also. This is they'll ask. That is has said. Duplicate rejected. That is you should remember. Okay. So if you write like this also, what will happen? 5 only comes. If you write null, null accepted, but 6 comes now. Null is accepted. Now see, null is there. But it is somewhere stored, you observe. Somewhere it is stored, null, one place. What is there inside algorithm? We cannot see. Just I explained with the data structure concept. 7 algorithms are there. Which algorithm written also we do not know. Just I explained to understand. Because that is method body already written. Okay. So null, it is accepted. Null accepted, duplicate rejected. Okay. Write this example also. Here with index based, no searching, only element based searching. Index we should not use. What is the output? Here. 6. Duplicates automatically rejected. 1 minute. Is it over? Writing is over? Oh, not over? This is the output. Not on. Here, duplicate elements are automatically rejected. Here, duplicate elements are automatically rejected. Here, duplicate elements are automatically rejected. Is it over? Your duplicate elements are automatically rejected. Now, this is about hash set. Next, linked hash set. It is an implementation of hashing technique with linked representation. It is an implementation of hashing technique with linked representation. It does not allow duplicate elements because it implements set interface. It allows null value. Hashing, no need to write, already written. Write this one. Write this one also. Write this one also. It supports both homogeneous elements and heterogeneous elements. So linked hash set also hashing technique, but only difference linked representation. It does not allow duplicate elements because set implementer base. It allows null value. It supports both homogeneous and heterogeneous elements. Linked hash set default initial capacity 16. Here also same. Default load factor is 75%. Here insertion order is preserved. As set is an unordered set. Linked asset. Linked asset is an ordered set. It occupies more memory because data stored in nodes. It occupies more memory because data stored in nodes. Node, how many parts will be there? three parts. What are those? Left link field, data field, right link field. Left link field contains previous node address. Data field contains next node. Right link field contains next node address. Okay. It is double linked list concept. Single linked list is not implemented in Java. It occupies more memory because data stored in nodes. Because every element left, right, previous node, next node address maintained. That's what more memory. Okay. Even this all information available in internet also. Just if you open library, API documentation, see java.util.linked list. If you write here, you observe documentation part, linked list. See linked list, it is linked list library, linked asset if you want. Linked asset you can type. Linked asset. See, linked asset, if 20 version if you want, 20 if you write 20 version, latest version. Documentation not available, old version comes. Okay. Now, here, see linked asset, derived from abstract set, collection, object. Like this information about this, complete information available here. See, this is a member of collections framework. 1.4 version it is released. See, initial capacity 16, 0.75, nothing but 75%. Okay. Like this default initial capacity and load factor. You can specify initial capacity. Again, load factor 75. Here you can specify capacity, you can specify load factor. Based on that also it works. So many your methods are not there. That means superclass methods only can use. Superclass is asset. Okay. That is about linked asset. Complete information available. See, this all. But this all exact point wise I given. Whatever required. Okay. So here concepts are which representation method used, which technique used, and duplicate allowed or not allowed, null value allowed or not allowed, load factor, and default initial capacity, homogeneous, heterogeneous, supported or not. These type questions only they'll ask. Insertion order preserved or not preserved. Is it ordered set or in unordered set? That type. Will it occupy less memory or more memory? Any concept. These are the points required. Okay. Now you observe. Same program, just linked. Here I'll add linked. Now disorder maintained. My order only comes. File, save. You observe. Whatever I given 83, 45, 32C, 17, 68, 45 rejected. One duplicate rejected. Okay, it is automatically rejected. Here, now my order null is here, null came. Maybe null in previous, what will happen? Wherever first empty is there, they're placed. I think that is the return. First location empty place. Maybe that is placed in one place at a time. Okay. This is linked asset. But writing programs are same. Array list also same. Linked list also same. Asset also same. Linked asset also same. Internally different. If you want unordered set, high performance has set. Ordered set, this one. Like that you have to select. One more sorted set is there. That is tree set. Next concept. Write this one. Example. See, output is 83, 45, 32, 17, 68, null. Next, six elements. 45 duplicate is there, automatically rejected. Is it over? Has set, linked asset. Has set, linked asset. What are the differences you identified? Asset, linked asset. What are the differences you identified? Insertion order, here preserved. There, that is one difference. Next, it is ordered set. That is unordered set. Next, it occupies more memory. That occupies less memory. Next, that is array representation. This is linked representation. These are the differences. Okay. Now, next concept, tree set. Next concept, tree set. It is an implementation of red black tree technique with linked representation. It is an implementation of red black tree technique. It is an implementation of red black tree technique. Then it is an implementation of red black tree technique with linked representation. What is red black tree required? Red black tree. It is similar to binary search tree. It is similar to binary search tree. Little difference is there. The difference I'll show you. Binary search tree. A binary tree is said to be binary search tree. A binary tree is said to be binary search tree if it is follows the following rules. A binary tree is said to be binary search tree if it is follows the following rules. If the element is less than root element, then it must be in left subtree. If the element is greater than root element, then it must be in right subtree. A binary tree is said to be binary search tree if it is follows the following rules. The element is less than root element, then it must be in left subtree. The element is greater than root element, then it must be in right subtree. The element is less than root element, then it must be in left subtree. If the element is greater than root element, then it must be in right subtree. Now, see first point what I given, see tree set. Tree set first point. What is tree set? It is an implementation of red black tree technique with linked representation. It is not array representation. See, has set, linked as set. Has set is array representation. Linked as set is, but this is tree set. But class name linked tree is that not there. Tree set only linked. But array representation trees, then generally they won't use memory, lot of memory wasted. That is the reason they won't use. With array representation only wasted. How? I'll explain. See, sometimes trees, what will happen? Trees like this comes. This right side. This tree right side. Again, this tree right side. If this type of trees comes, no memory, lot of memory wasted in array representation. Then what will happen? This node number 0, left side 1, right side 2. Again, this left side 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then here total how many nodes are there? 4, but 16 elements allocated. Next to one more, if it is right side comes, 32 also allocated. Next one more right side comes, 65 comes. Memory wasted. That is the reason they won't maintain in array. That's what it is binary. It is linked representation. Class name is tree set. Class name is tree set. It is an implementation of red black tree technique with linked representation. Technique is red black tree. Representation is linked. What is red black tree? It is similar to binary search tree. What is binary search tree? A binary tree is said to be binary search tree if it is follows the following rules. If the element is less than, it should be left side. If the element is greater than, it should be right side. But if the element is same, if the element is less than, left side, greater than, right side. But if the element is same, what will happen? You already studied rejected. It is rejected, no? It is set. Set does not allow duplicate. Same element will not come. This question they'll ask in interview. Few people will give left side, few people give right side, center they'll give. That type. Okay. Actually, it is a set. It does not allow duplicate. Okay. Here and also binary tree. What is binary tree? No. A binary tree is a tree in which a binary tree is a tree in which each node has maximum 2 child nodes. A binary tree is a tree in which each node has maximum 2 child nodes. A binary tree is a tree in which each node has maximum 2 child nodes. So for node, this is one node. For this, left side one child node, right side one child node. Like this it maintains. Okay. Either here no child node, here no child node. For this one, 2 child nodes. Otherwise, one child node here. But 0 also okay, 1 also okay, 2 also okay. 3, it is not allowed. 3 also possible. B trees, B plus trees, 3 child node, 4 child nodes also possible. That type of child nodes also we can maintain. Addresses many. But only first node number, that is nothing but data. Next addresses. B trees, B plus trees also concepts are there. In your academics, data structures you studied in a first year, I think. Okay. So data structures not so easy. Here predefined, that's what easy. This type of program, if you want to write, if you want to implement, it will take more time. As well, one program, 200 lines will be there, minimum. Okay. AVL tree, B plus tree, 600 lines also will be there. Heap tree also 500-600 lines required. Okay. Here, those are not required for Java. Those are not required because already predefined here. Now, a binary tree is a tree in which each node has maximum 2 child nodes. Either 0 child node or 1 child node or 2 child node. More than 2 is there. It is not binary. Okay. Binary tree, if it is follows these 2 rules, that is called binary search tree. Okay. But what is red black? Actually, this concept is red black. Okay. See. Suppose one element 45. First 45 stored. Next element 62. Left side stored or right side stored? Right side. So 62. 63 something. No. First 45. Next 63 entered. 63 compared with 45, that's what right side comes. Suppose 97. First compared with 45, right side. Again compared with 63, right side. Suppose 55. Right side of 45, left side of 63. Like that maintained. Suppose assume 97 only here. Now, what will be happen? This tree. In this tree, now it is, can I call it first, can I call binary tree? Can I call binary tree? Binary tree means compulsory to, not too compulsory. Maximum 2. Binary means generally 2 word. But it is not compulsory 2. 0, 1, 2. More than 2 not allowed. Now, for this one child node. For this one child node. For this one, no child node. But all are less than 2. Okay. That's what. Can I call binary tree? Yes, it is binary tree. Can I call binary search tree? Yes, because greater than right side, greater than right side. This is binary tree also you can call. Binary search tree also you can call. You can call red black tree also. Red black tree is similar to binary search tree. But in a red black tree, what will happen? It is maintained like this. Automatically, root changed in a red black. This middle one, it becomes root. 63. 45. 97. Here, actually, which is a root element? 45. In a binary search tree, root element not changed. In a red black tree, root also changed. Memory saving purpose. Like this changed. Actually, here 45 is a root element. It is changed to 63. So just write it. In red black tree, first you write it. In red black tree adjusted. And is root element is changed. Whereas in binary search tree, whereas in binary search tree is not adjusted. In red black tree adjusted to save memory. Here root element is changed, whereas in binary search tree is not adjusted. Example, this is adjustment. That is one. Example, this is adjusted like this. So red black tree binary search tree is same. In this situation only tree adjusted to save memory. In other situation both are same. If this type of right side tree, right side only elements appears, in that situation only it will adjusted. So this tree adjusted to like this. So actually this is, which is a root element? 45. Here adjusted to 63. Changed. If it is binary search tree, not changed. As it is will be there. Red black tree adjusted. That is only difference. A red black tree adjusted to save memory. In binary search tree not adjusted. Then here root element changed. Here not changed. That's it. Is it over? Now, will it allow duplicates? No. Tree set does not allow duplicate elements because it implements set interface. Tree set does not allow null value. It will not allow null. Null is not allowed. Null if you write error, exception comes. It supports homogeneous elements only. It does not support heterogeneous elements. It supports homogeneous elements only. It does not support heterogeneous elements. Here, Initial capacity is 0. Initial capacity 0 means load factor is not there. Your default initial capacity is 0. It is an odd, it is a sorted set. It is a sorted set. Unordered, ordered, sorted. Your elements are sorted. Ascending order comes. It occupies more memory because data stored in nodes. It occupies more memory because data stored in nodes. You observe some points are different here. Okay. Initial capacity is 0, no memory. It is sorted. Here, not heterogeneous, not supported. And it will not allow null value. Okay. Some concepts are different, you observe. These all points important. These points only interview questions. Initial capacity, load factor, sorted or not, homogeneous supported or not, heterogeneous supported or not, duplicates are allowed or not, null value allowed or not. These all they'll ask. Less memory or more memory, which representation, which technique, everything. Writing program is very simple. Adding, removing, inserting, deleting, updating, these all. But points are important for interview. Okay. This program will see tomorrow. How it will become sorted, I'll show you tomorrow with a diagram. Tomorrow we'll see continuation.